So see the problems regarding time domain specifications here. So first problem, obtain the response of unity feedback system whose open loop transfer function is g of s is equal to 4 by s into s plus 5, and when the input is step input. So the question is, you have to find the response of the system. Okay, response of the unity feedback system. Unity feedback system, it means h of s is equal to 1. Remember all of you, here in the question itself, they have given it is a unity feedback system. So unity feedback system is nothing but h of s is equal to 1. Okay, and open loop transfer function they have given. So g of s is equal to 4 by s into s plus 5. Okay, and they have given input. What type of input, please? Step input. So that is the given data in the question. What you have to find? The response. Response is nothing but c of s. You have to find c of s. Okay, so for this you are drawing the diagram first. Okay, what is this diagram? It is a closed loop system. Okay, so here h of s is equal to 1. So you have drawn the feedback directly to the summation point. So this is the closed loop system. Okay, now so for this closed loop system you have to find the response. Okay, so what is the transfer function here? What is the closed loop transfer function formula? It is nothing but c of s by r of s is equal to g of s by 1 plus g of s into h of s. This is the closed loop transfer function formula. You know this, right? You know this formula. C of s by r of s is equal to g of s by 1 plus g of s into h of s. Okay, now based on this formula you have to find the response c of s. So before finding the response, so how can you find the response here? So if you want to find the c of s, so what will be the formula? C of s is equal to g of s by 1 plus g of s into h of s into what you have to write? You have to write r of s. Then you can directly find the c of s. So before doing that, first of all you are solving the g of s by 1 plus g of s. You are solving g of s by 1 plus g of s into h of s. H of s is nothing but 1, unity feedback. Okay, substitute g of s value. So what is g of s value? 4 by s into s plus 5 by 1 plus 4 by s into s plus 5. Okay, so now you are solving this g of s by 1 plus g of s into h of s. Okay, so taking the LCM, finally you are obtaining 4 by s into s plus 5 plus 4. Okay, now after multiplying you are obtaining the quadratic equation in the denominator. So for this denominator quadratic equation, what are the roots here? S plus 4 into s plus 1. Okay, now you have reduced the total g of s by 1 plus g of s into the form 4 by s plus 4 into s plus 1. Okay, now what you are doing, you have to find the response. So response in s domain, that is c of s is equal to r of s into 4 by s plus 1 into s plus 4. Okay, so now r is r of s. R of s is nothing but input. Okay, r of s is nothing but input. So you are giving the input, so it is a unit step. So what is the formula for unit step in s domain? It is nothing but 1 by s. So we have discussed it, right? We have discussed it. So if it is a unit step in s domain, you have to consider r of s value as 1 by s. Okay, now substituting that r of s value here, what will be the c of s? C of s is equal to 4 by s into s plus 1 into s plus 4. Okay, now see here. So you have to find the response in time domain. You have to find the response in time domain. So for reducing this c of s to the time domain, you have to solve this right hand side equation. What is that right hand side equation? 4 by s into s plus 1 into s plus 4. So you have to solve it. Okay, for converting c of s into c of t, that is nothing but time domain. So once again you have to do the partial fraction for this expansion. Okay, so 4 by s into s plus 1 into s plus 4. So here now this what is this type of partial fraction expansion? Is it first case, second case, or third case? It is first case. How you are saying it? So you have only the poles. Okay, you don't have any multiple poles, or you don't have any complex poles here. So now this is the first case method in the partial fraction, reduction of the partial fraction. Okay, so you can write directly that equation as 4 by s into s plus 1 into s plus 4 is equal to, you can write it as a by s plus b by s plus 1 plus c by s plus 4. Okay, so what are a, b, c here? Those are nothing but the residues. Those are nothing but the residues. So you have to find the residues here. Okay, so for finding the residues, so we know this method, right? How you are finding the residues? If you want to find the a value, so you have to consider only the denominator of a and c of s. Okay, so a is equal to c of s into s by letting s is equal to 0. Okay, so what is c of s? C of s is nothing but 4 by s plus 1 into s plus 4. Okay, by letting s is equal to 0. Substitute s is equal to 0 here. You will obtain 4 by 1 into 4. That is nothing but 1. Okay, that is the first residue. Similarly, how can you find the second residue? B value రావాలంటే ఏం చేస్తామా? C of s into denominator of b. What is denominator of b? S into 1. C of s into s plus 1 by letting, okay, so what is the s value here? S is equal to now minus 1. So denominator ఎంత ఉందో దాన్ని ఈక్వల్ టు 0 చేస్తే ఏమొస్తుంది? s value minus 1 అవుతుంది. Okay, so now after that substitute C of s here. 4 by s into s plus 1. So substituting s is equal to minus 1, you will obtain b as 4 by minus 1 into minus 1 plus 4, that is equal to minus 4 by 3. Similarly, you are going to calculate the residue c. C is equal to, what is c value? C of s into s plus 4 by letting s is equal to minus 4. Okay, substituting c of s, substituting c of s, you will obtain 4 by s into s plus 1 by letting s is equal to minus 4. Substituting s is equal to minus 4, the value will be 1 by 3. Okay, now whatever you have calculated the residues, you have to substitute those residues here in this equation. Okay, so c of s is equal to, final equation, what is c of s is equal to now 1 by s plus minus 4 by 3 by s plus 1 plus 1 by 3 by s plus 4. Okay, now you have to calculate the response in time domain. It means you have to do the inverse Laplace of c of s. Okay, so inverse Laplace of c of s is nothing but c of t, that is equal to Laplace inverse of 1 by s minus 4 by 3 into 1 by s plus 1 plus 1 by 3 into 1 by s plus 4. So what is Laplace inverse of 1 by s? The value is 1. Okay, similarly minus 4 by 3 into Laplace inverse of 1 by s plus 1, it is in the form of s plus a, right? So what is Laplace inverse of s plus a? Formula e power minus at. So you can write that expression as minus 4 by 3 into e power minus t. Similarly, the third value, that is 1 by 3 into e power minus 4t. Okay, what is the common part here? 1 by 3. So that is equal to 1 minus 1 by 3 into 4 into e power minus t minus e power minus 4t. Okay, so finally your response of unity feedback system C of t is equal to 1 minus 1 by 3 into 4 into e power minus t by e minus t minus e power minus 4t. Okay, so that is the response of unity feedback system. Okay, so this is the like this you have to calculate the response. Okay, so now see here you have the second example. Okay, so what is the second example? A positional control system with velocity feedback is shown in the figure. What is the response of the system for unit step input? So they have given the positional control system diagram. This is the figure. So for this figure you have to find the response. So what is the response? C of S. What is the input? C of t. Okay. So this is the positional control system figure. So the closed loop transfer function we can say it as C of S by R of S is equal to G of S by 1 plus G of S into H of S. So what is the G of S from the above figure? It is nothing but 100 by S into S plus 2, right? And H of S is nothing but 0.1 S plus 1. So is it a negative feedback or positive feedback? So your feedback has given to the minus sign, so it is a negative feedback system. So the formula is nothing but G of S by 1 plus G of S into H of S. So now by substituting the G of S and H of S value in the above equation, now C of S by R of S. So what is C of S by R of S now? It is 100 by S into S plus 2 by 1 plus 100 by S into S plus 2 into 0.1 S plus 1. Okay, so if you are going to solve this equation, you will get this equation. Okay, it is a quadratic equation. So for a quadratic equation you will have two roots, right? For this you have to find the what are the roots for that given quadratic equation. Okay, now the roots for this quadratic equation is a complex roots. Okay, if you are going to solve that quadratic equation, you are getting the roots as a minus 6 plus j8, minus 6 plus j8 and minus 6 minus j8. So those poles are nothing but the complex poles. Those poles are nothing but the complex poles, complex conjugate poles. So now, so as the roots are complex conjugate, the system is underdamped. The system is underdamped, and so the response of the system will have damped oscillations. Okay, now we have to calculate the C of S. Now we have to calculate the C of S. So based on the complex conjugate poles, so based on the input R of S is equal to 1 by S. Okay, C of S can be written as C of S is equal to 1 by S into 100 by S square plus 12S plus 100, that is equal to 100 by S into S square plus 12S plus 100. So for this now we have to do the partial fraction expansion. So for this it is a complex conjugate, so it is a third case of partial fraction expansion. So we are writing it as A by S plus BS plus C divided by S square plus 12S plus 100. Okay, so first of all you have to calculate the residue values for solving this. So what is the residues here? What are the residues A, B and C? How you are going to calculate A? A is equal to C of S into S by letting S is equal to 0. So 100 by S square plus 12S plus 100 by letting S is equal to 0, that is nothing but 100 by 100, that is equal to 1. So we calculated the residue value of A. Similarly, now you have to calculate the B and C. B and C. These can be calculated by cross multiplying the equation. Cross multiplying the equations. How you are going to cross multiply the equation? A into S square plus 12S plus 100 plus S into BS plus C is equal to 100. So denominators gets cancelled. So this will be the equation after cross multiplying. So now you have to multiply the values. So after multiplying the values, you will get this equation. After getting this equation, now we have to equate the quotients of like powers of s square and s. So what are the s square quotients? A and b are the s square quotients. So a plus b is equal to 0. Similarly, s quotients, what are s quotients? 12a plus 100, sorry, 12a plus c. Yes, 12a plus c is equal to 0. So from the first equation, s square quotients, a plus b is equal to 0. So what is a value? A is equal to minus 1. Okay, a is equal to 1. So b is equal to minus 1. Okay, now you know the a value. So by substituting the a value, you can calculate the c value also. What is c value? C is equal to minus 12. Okay, now c of s, by substituting the residue values, now c of s is equal to 1 by s plus minus s minus 12 by s square plus 12s plus 100. Okay, so now after solving this, so this denominator has to be written in the form of a quadratic equation, yes or no? So how you are writing it? So s square plus 12s plus 36 plus 64. Okay, s square plus 12s, okay, plus 36 plus 34. Yes, so now you are writing this, you are writing this 2ab. 2ab means nothing but 12s nala raskochuma, 2 into a is nothing but 1. Okay, so you should write the b value. So ఎంత రాస్తే మనకి 12 వస్తుంది? 6 రాయాలి. సో 2 into 6 అంటే 6 వాల్యూ మనకి b వాల్యూ ఏమవ్వాలి? 6 అవ్వాలి. సో b square is nothing but now 36. Okay, so now you got s square plus 12s plus 36 and the remaining value you have written as 64. Okay, after that you are writing that s square plus 12s plus 36 as s plus 6 whole square. S plus 6 whole square. Numerator also you are splitting like this. Okay, denominator plus remaining value is plus 8 square. Okay, so finally how you are writing denominator and numerator? You are separating the terms. How you are separating the terms? Like this, 1 by s minus s plus 6 by s plus 6 whole square plus 8 square minus 6 by s plus 6 whole square plus 8 square. So you can write this as okay, you can write this equation as 6 by 8 into 8 divided by s plus 6 whole square plus 8 square. Okay, for this now you are using the inverse Laplace transform. Up to here you have to simplify like this if you have the complex conjugate poles. Okay, so after applying the Laplace inverse, so 1 by s, what is 1 by s value? Laplace transform of 1 by s 1. It is in the form of s plus a by s plus a whole square plus omega square. So you know this formula, e power, how you are writing this? E power minus 60 into cos of 80. Okay, in the last classes we have discussed this formula. Okay, similarly 6 by 8, it is in the form of a by s plus a whole square plus b square. So you can write it as e power minus 60 into sine of 80. Okay, after writing this, what is the common part? E power minus 60. So 1 minus e power minus 60 into 6 by 8 into sine of 80 plus cos of 80. Okay, like this you have to calculate the time response of the given system. If you have the complex conjugate poles. Okay, so in the next class we can solve the remaining problems. So all of you solve these two problems, okay, on your own and write down in the class notes. Okay, and I will give the 2 questions as assignments. Solve those assignment questions. Thank you everyone.